So good afternoon everybody, myself Acharya Vishvendra, and today I shall be speaking on the topic of photoelectric effect. So let's begin with things. So let's begin with the question answer session first. So we are being given photons of energy E naught which are incident on a metal surface of work function phi naught, threshold frequency nu naught, threshold wavelength lambda naught. Then first thing is electron emission is possible when obviously energy should be greater than or equal to the work function. Next is it sure that electrons will come out? No, because electrons may collide with other electrons present in the metal, so there is just a probability of coming out, so they may come out is the right option. Next is relation between phi naught and nu naught is, so the relation is phi naught is equal to h nu naught. Next is if we draw graph between phi naught and nu naught, so graph will be a straight line and tan theta will be phi naught by nu naught which is equal to h, which is constant. Next is relation between phi naught and lambda naught. So the relation is C is equal to lambda naught into nu naught in vacuum. Next is if we draw graph between lambda naught and nu naught, so it's an inverse relation which corresponds to a rectangular hyperbola graph. Next is if we draw graph between nu naught and 1 by lambda naught, so nu naught is proportional to 1 by lambda naught which is proportional to x, so the graph will be a straight line. Next is if we draw graph between C and nu naught, so that will be a constant graph parallel to the nu naught axis. Similarly here it will be parallel to nu naught axis, here lambda naught axis, here lambda naught axis. Now there is a question that conditions on nu for photoelectric effect. So we know that frequency should be greater than or equal to the threshold frequency. So this will be the condition. Next is conditions on lambda for photoelectric effect. So condition is that wavelength should be less than the threshold wavelength. So this will be correct. Next is kinetic energy of ejected photoelectrons. So we know that photoelectrons came out with a spectrum of kinetic energy due to collision with the other electrons present in the crystal. So it lies between 0 to k max. Next is why photoelectrons have a distributed kinetic energy. So it's because of the collisions. Next is we need to find the relation between k max frequency and the work function. So Kmax is equal to h nu minus phi naught, and this equation is also called Albert Einstein's photoelectric equation. Next is we need to find a graph between Kmax and nu. So obviously this is gonna be a straight line with negative intercept minus phi naught and angle theta, where tan theta is equal to h, which is constant for all the frequencies. Next is we need to draw the graph between Kmax and nu naught. So obviously it is a straight line with negative slope and positive intercept. So here if phi naught is equal to 0, you can see that Kmax will be h nu, and if phi naught is equal to h nu, Kmax will be 0. So in this way the graph can be drawn. So these are the basic level worksheets to ensure that you know the basic facts, basic concepts and terms related to the topic. I'll be uploading the next level worksheets to check your advanced problem solving skills. So I hope this will prove to be boon to you and will optimize your time and energy. Thank you and have a nice day.